So pop quiz 5 related to alcohols and halogen alkanes. Some reactions of halogen alkane are summarized as you can see here. The halogen alkane is converted into amine. Here in reaction to halogen alkane is converted into alcohol. And the third one, halogen alkane, has reacted with potassium cyanide in ethanol and a compound M is formed. State the type and mechanism of these reactions. So whenever we have the halogen alkane, which reaction they undergo a nucleophilic. So the type of the reaction is nucleophilic, and the mechanism is a substitution reaction. If it was alkene, then alkene will undergo electrophilic addition reaction. The type of a reaction will be electrophilic and the mechanism will be addition. But in halogen alkanes, it will undergo a substitution reaction, which we also call nucleophilic substitution reaction. Because always the reaction happen by attacking on the positive center or the nucleophile. As this will be partial negative, carbon will be partial positive. Give an ionic name and the structure of compound M. So compound M is not shown, and we have uh, what it will result. It will result in a formation of a nitrile because like we have KCN. So in this KCN, potassium is positive and CN is negative. And here what will happen? C is positive and Br is negative. So in a substitution reaction, an atom or a group of atoms replaces another atom or a group of atoms. So this Cn will take position of a Br. So what will be the product? It will be H3C. C will be there. CH3 will be there. CH3 will be there. And Cn is there. So the compound which contain carbon and nitrogen bond, a triple bond is there. We call them as nitriles. The rule of naming remain the same. We always select the longest carbon chain. So what is the longest carbon chain? 1, 2, and 3. So these two carbon chains are considered as a branch. So which position we have a branch? Like if we count from here, 1, 2, and 3. So second position, we have two branches. So we can say this will be 2, 2. And each branch contain one carbon atom. So it is methyl. And there are two branches, two identical branches. So we call it as dimethyl. So 2,2-dimethyl, three carbon atoms, so it will be prop. They have a single bond between them, so it will be N. And because of this carbon and nitrogen link, we call them as nitrile. So it will be propane nitrile. So as a nucleophilic substitution reaction happen or occur, it will result in a formation of propane nitrile in this compound. So this is actually compound M. State the reagent and the condition for reaction 1. So reaction 1, because we want amine group to replace, so what we need, the reagent, we need ammonia here. So the reagent which we need for this reaction to happen or occur, we need ammonia. And what are the conditions? It should be because halogen alkanes are gases. So whenever we want to react them, we react them like ammonia, ammonia and halogen alkane, we both are gases. So we want to increase the rate of a reaction so they can collide with each other. So we use alcoholic solution, high pressure and alcoholic solution, as alcohol can dissolve both halogen alkane and ammonia, and the molecules can easily collide with each other. So conditions for reaction 1, the reagent, we need ammonia. And the conditions which are required, we required alcohol as a solvent. In part D, an incomplete mechanism for a reaction 2 is shown. As you can see here, the reaction 2 is the conversion of halogen alkane into alcohol. Complete the mechanism by adding the curly arrows, the relevant dipoles, and a lone pair. Describe how intermediate J is formed in first step and naming the process that occur. So first thing, when we want to make a dipole, so bromine is more electronegative than carbon, so bromine will be partial positive and partial negative, and carbon will be partial positive. That's the first thing. Then what will happen? Because as you can see, the bromine atom took the bonded electron. So this bonded electron is taken by the bromine. So we'll draw the curly arrow towards the bromine. You can draw in this way that it took both of these electron pairs. Then this oxygen will have a lone pair, and this lone pair will be attracted towards the positive, and as a result it will form an alcohol. And describe how J is formed in first step. So how J is formed, what kind of bond breaking happen or occur? Because it's forming the ions whenever ions are formed. So which type of bond breaking happen? That is a heterolytic. So there's a heterolytic bond breaking that happen or occur here. And why this happened? Because the bonded electron, both of the bonded electrons are taken by bromine. So the bonded electrons are taken by the bromine atom because it is more electronegative. State the shape of intermediate and justify your answer. Whenever we predict the shape, we check the central atom. So the central atom is carbon. And for this central atom, we check how many bond pairs are there and how many lone pairs are there. So how many bond pairs are there? This is one bond pair. This is second bond pair, this third bond pair. So three bond pairs are there. And how many lone pairs are there? There is no lone pair on carbon. So three bond pair and no lone pair. So if three bond pair, then it will be trigonal planar with a bond angle of 120 degrees. And the bond angles are always adjusted to minimize the repulsion. So here we have to predict, state the shape and justify your answer. So the shape is trigonal planar. And the reason the the electrons arrange themselves to minimize the repulsion. In part 2, describe how the J is formed in first step. How this J is formed in first step? Because what will happen, these two electrons, the bonded electrons are taken by the bromine. When the bromine will take both of these bonded pair, bromine will get a negative charge and the carbon cation will be a positive charge. So because the unequal breaking of the bond, or it's a heterolytic bond breaking in which one of like both electron pairs are taken by one of the atom, so it will result in a formation of ions. If it was a homolytic bond breaking, then what will happen? Both of them take their electron and it will produce a free radical. In a heterolytic bond breaking, what happened? That both of the electrons are taken by one atom and it's result in a formation of charges, positive and negative charges. The product of the reaction 2 is shown, as you can see here. This compound has three isomers that are also alcohols. Draw the structure. So this is one of the isomer is shown. We can draw, this is a like the maximum branch. One is given, three branches are, two branches are there. So what we can do, we can first draw a straight chain and OH will be attached with the first one. They did not specify what kind of, like they just mentioned draw the structure. So you can draw a displayed formula, you can draw a structural formula, or you can draw the skeletal formula. Because in this question there's, but otherwise some question they specify draw the skeletal. So a skeletal formula is much more easy to draw as it saves the space as well. So 1, 2, 3, like 1, 2, 3, 4 are there. So 1, 2, 3, 4 carbon and then OH. So this is actually butane 1 all. Then we can make a branch, three carbon atoms and one branch, like three carbon in a straight chain and one branch. And two and like three and one branch is, but if you see this one, the OH, what is the difference between this structure and the structure which I drew? So this is the first carbon, second carbon, and third carbon. So second carbon is having a branch and the first carbon is having OH. And what is this? What about this structure? Second carbon is having OH and second carbon is having a branch. So they are not similar. They are different from each other. And then we can change the position of OH. So 1, 2, 3, 4 are there. And we just change the position of OH. So OH is attached with the second carbon. So these are the three different structures. The first one is a straight chain. The second one is a branch. The third one is a position isomerism. Isomer means we change the position of OH. Is it clear? The three isomers of alcohol. Any doubt till this point? Yeah, this will be correct. If you draw the displayed formula, that will be fine. Because in the question, they did not specify that, they just mentioned draw the structure. They did not say draw the skeletal. So it's fine if you show the displayed formula. Skeletal formulas are important, like using a skeletal formula. Usually in exam, they ask for skeletal formula. The next one, the reaction of halogen alkane with hydroxide is often carried out in sodium hydroxide or potassium hydroxide. An alternate, sorry, an alternative is a moist silver one oxide, which is prepared by adding few drops of water into a solid silver one oxide. Silver one oxide is insoluble, but produce sufficient hydroxide ions. Write an ionic equation for a reaction of silver one oxide with water. State symbols are not required. So silver one oxide, which is prepared by adding few drops of water, the moist silver one oxide can be prepared. So we want to write an ionic equation here. As I mentioned, silver 1 oxide is insoluble. So silver 1 oxide, Ag, what will the formula of silver 1 oxide? Ag is plus 1, oxygen is minus 2. So silver 1 oxide will be Ag2O. And we added water, so it will be H2O. As a result, what they mentioned, they produce sufficient hydroxide ions. So the ions which are produced here is hydroxide. Then what will be the other ion? So the other ion will be silver, because hydroxide ions are coming from water and this oxygen is also removed. Then we just have to balance this equation. Whenever you balance, start with oxygen. So here we have 2, so we put 2. And we have, so oxygen is balanced, hydrogen is balanced, and silver 2. So we put 2, so silver is also balanced. Because they mentioned here it is producing hydroxide ion, so one of the product is hydroxide ion. So if one of the product is a hydroxide ion, so other product should be a silver ion, because it is already silver 1 oxide, so there must be a silver ion present. And the state symbols are not required, but if they ask for a state symbol, so this is solid, water will be liquid, this will, ions are always aqueous, so this will be aqueous and this will also be aqueous. So just one advantage of using silver 1 oxide rather than sodium hydroxide or potassium hydroxide. So main reason, when you're using like alkalis like such as potassium or sodium hydroxide, these alkalis are corrosive, the main reason. And another thing is, if you see the difference, that so if you are using a sodium hydroxide, like if you use a sodium hydroxide, it provide a hydroxide ion, and you are using a silver 1 oxide to produce a hydroxide ion. If you have more than enough, or you have an excess of a silver 1 oxide, so the silver 1 oxide is solid, but sodium hydroxide is in aqueous. So if you add excess of sodium hydroxide, you cannot remove an excess. Like if more than enough sodium hydroxide is added to a mixture, you cannot remove that because it is aqueous. Where if you add more than enough sodium 1 oxide, because it is in solid, so excess can be removed by filtration. So that is an advantage. Like we'll not have, even if we added excess quantity of a silver 1 oxide, but because it is a solid, so it can be separated from the mixture by filtration. But sodium hydroxide or potassium hydroxide, as they are aqueous, the solutions are there, so it will, we cannot separate them from the mixture. That is another advantage. Corrosive also, you can mention corrosive, that's also another one. Question 2, the structure of 3 bromo alkanes P, Q, and R are shown. Which of them classify as tertiary? To be a tertiary, we check the carbon which is bonded with halogen alkane, halogen should have a 3 branches. So if you mark this carbon, so this is 1 branch and this whole is second, 2 branches. So secondary. If we mark this, so this is primary. If we mark this, so this is 1, 2, and 3 branches, so this will be tertiary. So in that case, C should be the right answer, because the tertiary compounds will have 3 branches. In question 3, when 1 chlorobutane is mixed with ethanol and silver 1 nitrate, a reaction occurs. Which species are nucleophile in this reaction? So we have 1 chlorobutane. First position, a chlorine is there. This will be CH2, 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 and CH3. This will be partial positive, negative, and the carbon will be partial positive. And silver 1 nitrate is added, so AgNO3 is added. The nucleophile means which attack on the positive center. So actually the nucleophile is the OH ion. And from where this OH ion will come? This OH ion will come from the water, because this is aqueous silver nitrate. So the water will have H plus and OH minus. and this OH ion will attack on the positive center. So this OH is acting like a nucleophile, because nucleophiles means like electron loving site, nucleus loving sites. So means they are attracted towards the positive center. So in this case, because it will form, first when a reaction will happen, it will form butanol, and then the chlorine will be removed, and that will combine with silver to form silver chloride, which will be a white PPT. So which ion, if it was a hydroxide was written, then we'll select the hydroxide. But because the water is written, so we'll select water, as the water break down into H plus and OH minus, and this OH is actually attacking on the carbon positive, or it is attacking on the positive center. That's why we call that as a nucleophile. Is it clear? Question 3. Why it cannot be nitrate? Because the reaction does not involve a nitrate is a spectator ion here. When we have CH3, CH2, CH2, CH2 and OH and Br. So nitrate ion is actually the spectator ion. It does not change. So Br is negative, this is positive. Now what will happen? We add an aqueous silver nitrate. So when we add aqueous silver nitrate, so there will be Ag plus ion, there will be NO3 minus ion, there is H plus ion, and there is OH minus ion. H plus and OH minus are because of the water, and Ag plus and NO3 minus are due to silver nitrate. All nitrates are soluble. So what will happen? Because the OH attack on this, so as the OH is attacking, and as a result of the attack of OH, what it will form? It will form CH3, CH2, and this is basically alcohol, like alcoholic medium. So whenever alcoholic medium is there, it will result in a formation of alkene. So this will form CH3, CH2, CH2, CH will be there. Like elimination reaction happen. So the nitrate ion, because of its greater size, is not able to attack or on this as compared to OH ion. So that's why the attacking nucleophile, you can consider OH or you can also consider water, because alcoholic medium elimination reaction will happen or occur. Is it clear? Question 4, propane 1 all may be converted into propene. As you can see here, which reagent? So this is alcohol is converted into alkene. So we want this reaction is known as like dehydration, like removing the water molecules from a substance. So we need this reaction. You have to learn the reaction condition when alcohol is converted. So we need a phosphoric acid for that. Certain reaction condition, the conversion of alcohol into alkene. So phosphoric acid is there, and best classification as like how we can classify what type of reaction is this. The water elimination. Look, the correct answer is it's hydrolysis means if water is a reactant, then hydrolysis. But water is not a reactant; it's a product. Reduction means it's a removal of oxygen or addition of hydrogen. But there is, if it was a reduction, but this, it is removing H and OH, both are being removed. Not like the definition of a reduction, oxidation is addition of oxygen, reduction is a removal of oxygen or addition of hydrogen. But what happened here, in this compound, H is removed and OH is also removed. So both are removed rather than added. That's why we cannot classify as reduction. It's not a substitution, like not a group of atom replaces another group of atoms. So it's not a substitution, so it is simply elimination. So A will be the right answer. So part A is actually related to memorizing the condition, and part B is identifying what kind of reaction will happen or occur.